Hello viewers, you're welcome to this lecture on hydrobiology. Today we are going to discuss about the carbonate bicarbonate system and pH, basically how the carbonate bicarbonate system affects the pH of the ocean. Now, what is the carbonate bicarbonate system? The carbonate bicarbonate system is a crucial buffering system that maintains the pH balance in biological systems like the human blood and in natural waters such as the oceans. Basically, the carbonate bicarbonate system helps to maintain a pH range that is suitable for the aquatic organisms. It consists of carbonic acid, bicarbonate ions, and dissolved carbon dioxide in equilibrium. And this system is very crucial to ensure the survival of marine organisms, especially the shelled fishes. The reactions involve the following. First, this system involves a series of reversible reactions that allow it to absorb or release hydrogen ions to counteract changes in pH. So the system is capable of absorbing hydrogen ions or releasing hydrogen ions, and the absorption and release of hydrogen ions basically affects the pH of the water. Now let us look at the first step. The first reaction is the dissolving of carbon dioxide. Carbon dioxide gas dissolves in water to form carbonic acid. So basically you now have CO2 plus H2O, which eventually results or gives rise to carbonic acid. Now, the second stage is the formation of bicarbonate. Carbonic acid is a weak acid that readily dissociates into hydrogen and bicarbonate ions. So basically, carbonic acid releases a proton or hydrogen to form bicarbonate ion. And basically, this is a reversible reaction. The carbonic acid basically can be converted to the bicarbonate ion and vice versa. We want to look at basically how this system, the carbonate bicarbonate system, is able to resist changes in the pH in the ocean. This buffering system, the carbonate bicarbonate system, is based on the Le Chatelier's principle, which states that a system in equilibrium will counteract a stress placed upon it. So a system, the ocean, that's in equilibrium, having a specific pH range, is able to counteract any change in pH as a result of the addition of carbon dioxide. Now, how is it able to do that? Now, when an acid is added into the ocean as a result of the introduction of carbon dioxide to form carbonic acid, the excess hydrogen ion are consumed by bicarbonate ions to form carbonic acid. This shifts the equilibrium to the left. That means it basically helps to prevent a significant drop in the pH. The removal of excess hydrogen ions by combination with the bicarbonate ions help to resist change in pH. Now, when a base is added, on the other hand, the carbonic acid dissociates to release hydrogen ions, which neutralizes the added base. So this actually prevents significant rise in the pH. So it prevents the water from being alkaline. It prevents it from having alkaline pH, or making the pH to rise above the 8.5 optimum pH for aquatic organisms. Now, one implication, the application of the carbonate bicarbonate system in ocean chemistry is one application is the ocean acidification. The ocean is naturally buffered by the carbon system or the bicarbonate system, which actually helps to maintain the pH of about 8.1. Though the optimum pH for living organisms is between 6.5 to 8.5. Though this pH is now being affected by human activities such as increase in fossil fuel and other greenhouse gas emissions, which have introduced too much carbon dioxide into the atmosphere, and this carbon dioxide is being absorbed in the oceans. The increase in carbon dioxide actually increases the concentration of the carbonic acid in the ocean, which reduces the pH, makes the pH to be acidic. This process, known as ocean acidification, decreases the available carbonate ions, and this actually affects marine organisms because they need this carbonate ions to build the calciums in their shells and their skeleton. So eventually it now begins to affect the formation of the shells of some mollusks and some crustaceans and the skeletons of some of these shelled fishes. So basically, that's how the ocean acidification adversely affects the living organisms in the ocean. So the oceans play a very crucial role in maintaining pH and in helping to remove carbon dioxide. But too much carbon dioxide emission actually affects the oceans adversely. Thanks a lot for watching. I am Dr. Gijo Harry.